All right, so in our first, yesterday's assignment, we started writing exponential functions. And so today we're going to be looking at those exponential functions and how do they behave on a graph. And so let's go back to one of the questions that we had a while ago where we were given a penny for an allowance the first week, and then it was going to double every week for an entire year. We ended up with a huge amount of money on the 52nd week of the year. But let's just say here's week 1, and week 2, and week 3, week 4, week 5, and so on. And then here we have, let's say this is $1, and here's $2, and here's $3, and here's $4. Let's just see what this graph is going to look like. We know that on the first week we had, well, let's just say at the beginning you got paid 1 cent. And then after 1 week you got 2 cents, and then it went up to 4 cents, and then it went up to 8 cents, and then it went up to 16 cents after 4 weeks, and then after 5 weeks it went up to 32 cents, which would be about here, and after 6 weeks it'd be 64 cents. After 7 weeks it would be $1.28, which is roughly in this area here. And so we have to wait 7 weeks before we get over $1. But after that, the 8 weeks, it would be, let's see, $1.28 times 2 would be $2.54, which would be about here. And then after 9 weeks, $2.54, if we doubled that, we would be at $5.12. And so now we're already off our page. You can see that for a while, this was growing really, really slowly. And all of a sudden, it starts to skyrocket. We would not, even the 10th week, we would be so it'd be off the computer screen. This is an exponential growth function because it starts growing slowly, but as time goes by, it just shoots way up there. One of the things that I want you to see is that the general form for this situation would have looked like this. We would have started with 1 penny, and it would have doubled X number of times. We could have also written it like that. But remember, this is where it starts. So that's where it crosses the y-axis. It starts with a penny, and then this is the growth factor. Every time we move 1 space to the right, it doubles. So it went from 1 to 2 to 4 to 8 to 16 to 32 to 64 and so on. And so this is the equation that this graph here is displaying. If we look at another similar situation that we've talked about, and that is that let's say that you remember half of everything that you're taught in one day. And so let's just say this whole thing is 100% or 100 things in one day. So this would be 75 here, this would be 50 here. Here we would have 25% left, and this is, you remember nothing. So let's say on a given day you're taught 100 things, or 100 things happen to you. That's day 1, or at the beginning. After 1 day, you only remember half of that. So on the second day, you remember half of that, which is 25%. On the third day, you remember half of that, which is 12.5%. On the fourth day, you remember half of that, which is, let's see, 6.25%, something like that. And so it just keeps cutting in half and half and half and half. Would it ever be that you forgot everything? And the answer to that would be no. It'd get really, really close to approaching the horizontal axis, but it would never cross it. There's a kind of like a dotted line here that we call an asymptote. That means that the line approaches it, but it never touches it. And so this is actually not exponential growth. This is an example of exponential decay. And the reason it's exponential decay is because it's not growing like the last one where it started off slow and grew. It's actually just the opposite. It's shrinking really fast, but then it starts to shrink really in small amounts as it gets closer and closer to the x-axis. And so the general form here would be something like, the general equation would be y equals 100 because that's what you started with. If you remember half of it, the growth factor is going to be 0.5 to the x power. And so that is what this function would look like if we graphed it. Let's just take a look at some pretty easy exponential equations and see if we can figure out what the graphs of these look like. So let's just start with this, y equals 3 times 2 to the x. Where does it start? Well, it starts right here at 3. So I'm going to put a point there at 3. But then every time I move one space to the right, it's going to double. So because the growth factor is 2. And so after one space to the right, it's going to be at 6. If I moved another space to the right, it'd be at 12. And so that's going to be way up in this area up here, which is well off my graph. If I moved back a space, if I moved, somehow I got to 3, but if I moved back, I would be not double that, but half of it, which would be at 1.5. And then half of that moving in this direction. And so I would have an asymptote here at the x-axis. It's never going to cross the x-axis, but it would start really, really close to that, and then it would shoot up like this. This is an exponential growth equation because the growth factor is bigger than 1, and it's going to be getting bigger as we move to the right. Let's take a look at the second example here. Where does this graph start at? Well, this starts at 8, which is right here. But then the growth factor is 1/2. That means every time we move one space to the right, it's going to be half as big. So what's half of 8? Well, that's 4. What's half of 4? That's 2. Half of 2 is 1. Half of 1 is 1/2. Half of 1/2 is 1/4. And it's going to get closer and closer to this asymptote. It'll always have an asymptote there, but it will never cross it. In other words, it's going to look something like this. And if we went back in time, it's going to shoot way up there because in order to get this 8, I had to take half of something here, which would be at 16, and then 32, and so on. And so these are not straight lines. They're curves. They're not parabolas. They either start really close to the x-axis and shoot way up, or they start way far away from the x-axis and shoot down and become almost parallel to it. These are the type of graphs that we're going to be doing for our homework today, and we will go over questions that you have on it tomorrow in class.